start recording for your colleagues. So today we will start looking at Prolog, a logical programming language, a completely, I would say, different approach to what the languages you are used to. Those who are taking, of course, AI course have seen some of the predicate logic we've been using. But yeah, so if you're used to using Python or C++, it will be a different approach. And again, it's not for every occasion, but sometimes it's really nice to have this tool in your sort of like toolbox, right? You have some sort of kind of particular type of problem, like a logical problem. A Prolog might be a very nice approach, make your code very nice and short and sweet. All right, so let's see the materials. I'll be using, let's see what I have on code spaces. Actually, I might have a notebook. The challenge, of course, will be that this is I would say the least practical language. Well, not the least, I mean, it's not a language you use as a sort of like your bread and butter language, basically, right? Not like Python, not like C, not even Clojure. Clojure you can use for everything as well, but Prolog is suited for particularly solving sort of puzzle-like logical problems where you can set up sort of conditions. So instead of telling computer what to do, the main idea, you tell computer what you know. You tell computer some facts about the world, some ways that these facts relate to each other, and then you say, okay, and then the magic happens. You say, computer, solve this for me. Tell me something about my facts. And it will tell you new facts, you know. Very cool for certain things, really nicely. The bad side, of course, is that it's not really, if you try to do too much of it, then it becomes painful. And also, unfortunately, there's no big commercial company behind it, right? So here's what I was talking about, right? So there's two things, basically. So facts and rules, basically. Facts and rules, and then you have queries. So you set up these facts and rules, like somebody likes something, right? So you can set up a fact, likes, again, using regular language, right? Likes is up to you what you want. It's not set in stone, and you say John and pizza, right? That's the fact that John likes pizza, right? But then you can also say friends are whether those who like common things, right? Friend X and Y, they share common love of something. I don't know, it could be chess, could be pizza, could be Prolog programming, but you know, those could be strange friends, right? But yeah, so that's the idea. And then you backtrack, meaning you ask for it, right? And you basically Prolog will tell you, right? And that's it. So what's interesting again, so variables in Prolog start with a capital, right? So the language is sort of weird, right? So what is a variable? Like, it's very typical to use variables, one letter variables, but I would suggest use bigger, longer variables, right? So you see here, John likes apple, query John likes what? You will see who John likes something, right? So let's see if you can do. We'll get some practice with this today, right? There is a nice playground offered by this. Actually, situation is better than I took it like 20 years ago. This language, because then the tooling was really bad. Now you have at least something like looks like a notebook, right? But let's look at what history first, right? Maybe you can have some history. So basically, it's based on so-called first-order predicate logic, right? So idea was that we set up facts about the world, and these facts will lead us basically to general AI. Basically, that was the idea. Well, so it's French. I don't speak French, unfortunately. So programmation and logique. I don't know. I can't pronounce. Any French speakers here? No. All right. So yeah. So it was basically this pattern matching idea, very powerful. Like so. Again, Japan in the 80s they thought, okay, this is going to solve all the problems with AI. Basically, it's the last AI boom, basically, right? It's a reminder of this, right? So, luckily now, what situation is this? It's not mainstream, right? But there's a standard for it, right? There's decent implementations, right? So, University of Edinburgh. If you want to really, you really like Prolog, you should probably head to University of Edinburgh, right? That's like the hotbed of Prolog development, right? Again, if a big company like Meta or like Google took over Prolog development, it'd be really nice. I think there'd be some big, I would say, improvements in usability, I would say. because again, I think, like I said, I think Prolog has a space, has a place in AI, and still has it, right? LLM is not going to solve all our problems. So setup, again, SVI Prolog is the most popular one. You can download locally, right? You can install it here. Let's see if we can install it today on our local machine. Well, in my case, I have a code space, right? Ubuntu machine. Let's see what happens. Can I do it actually? That might be a good start, right? If you have, so it will be easier. You can do this for course. I mean, you can do everything with the online Swish notebook. Yeah, this here, Swish SVI Prolog, right? This one here, right? This address, Swish SWI Prolog, right? So this will let you actually create some queries. So you can use notebook or program. So you have two things, right? Program or notebook. So let's do a program cell here. Right? Let's head there, right? And afterwards we'll do installation. Let's run a little hello world here first, right? So let's do a cell. I'll do a program cell, right? So your Prolog rules and facts go here, right? So let's see if we can put some facts about liking pizza, right? So likes, right? I'll do Valdis, right, with lowercase, because that's just like a constant, right? And I like pizza, right? So I'll do dot, rot stops, it's like a line ending, okay? Let's do one more. And the thing is now, can I do more facts? Because I don't want to run the cell yet, right? It's kind of similar to like what I've been using for Python, right? But I don't want to run the query yet. It's, yeah, okay, good. So I can press enter, right? So I can press enter, right? What else do I like? Likes, well, this likes chess, right? All right, another fact, right? Right. Likes Riga likes pizza, right? And so that's so far, all right? And let's do that inference rule, all right? Let's do the inference rule. We want at least one rule, right? Since I'm lazy, all right? Friend, right? So friend, right, is somebody, x, y, those are variables, right? And this is the implication, right? So they have common interests, right? Likes, x likes z, again, it's up to you, you know, item, I could say, you know, something, you know, something would be okay as well, L2Z. I mean, it's very common to use these variables. So that's, I think, is also one of those things, like, yeah, Prolog programmers like to use these one-letter variables, so that makes, for longer programs, you should use something more descriptive, right? Okay, so I have friend, likes, and friend. Okay, so let's run this. This is my knowledge base so far. Very, like, what else do I like, right? So pizza and chess, and Riga likes pizza, right? So let's run this query. I'll run everything right here. Let's see. So I need to, of course, update this database, knowledge base, right? Let's do this. Let's see if my syntax is okay. Come on, I want to run it. Did I press it or not? I can't tell actually. Or run all. I think I did run it. Well, let's take a look here. I'll do a query, right? I'll do something really stupid, right? So likes, well, this pizza, right? This is not very interesting, of course, by the way, right? Now do I see, I think I need dot. Let me see, run or is error? True. No, I don't need an error. Okay, so basically, this is a true statement. Okay. So how about, do I like anchovies, right? In fact, it's not in a database at all, right? It's going to say no, false. It's false, right? Because it's not even in a database, right? So you might, this moment you say, okay, but how the hell do you, sorry, pardon my French, but how do you make a program out of this, right? It's so nice for the queries, right? You'll see, you actually, what's kind of fascinating is this actually is Turing complete, actually. That's the fascinating thing about this language, right? So, okay, so this is the basic idea. So let's do something more interesting. What do I like? My favorites, right? I'll call something like this favorites, right? Okay, so this is a variable. It's an open-ended. It's not unbound, right? Favorites. Can you guys see this? Yeah. So I'll run my query. So what do you expect should happen? Well, let's take a look.
False.
No, it's not false, because what's happening? The inference engine, sort of the reasoning engine of Prolog, goes through the facts, the knowledge base, and starts matching. So in this case, favorites is assigned to pizza, well, as expected, right? So, but that's not all, right? Because this is the unbound variable, right? I mean, there are more than one likes, right? So I can assign this also, next one, right, to chess, right? And then I do one more time, actually that's it, right? So knowledge base is exhausted, right? That's it, they cannot find anything else, right? So kind of cool, right? You can ask, okay, what does Valdis like? And you get all the knowledge back. Kind of similar to databases, right? If you have maybe some basic idea of databases, but not, it's kind of roughly the same area of IT and computer science, but not quite, right? There are different ways this engine works, right? So you can sort of use like the database, right? So favorites. All right. So that's also cool, but let's do this something more interesting. So let's ask: is Valdis and Riga friends? Are they friends? Right. So XY, right? Let's take a look. Is this the correct implication? So it looks like okay. So Valdis is X, Riga is Y, and so basically the inference engine will look for a common interest, right? It will try to find the place in the knowledge base where both Z is equal. So in this case, we see they both like pizza, right? So that means they should be friends, right? When I said likes, not oh, Valdis likes Liga, no, sorry, that may be true, but friends, they're just friends for now, right? All right, let's run it. Okay, let's take a look. And it's true, right? So why is it true? Because by substituting X and Y, right here, it follows, it could find if friends are those who have common interests, basically. Does this make sense so far?
Mm-hmm.
Yeah. So again, for small examples, I think it's very clear. The issue which is based with this language, of course, it's kind of fun to play around as you start building a larger system, right, of knowledge base, right? You might get basically, I would say it's rather hard to debug, right? If you make a mistake, that's I think is the biggest weakness. If I must say again, because of my own personal painful experience a long time ago, I've grown to like it actually. I mean, but I don't really get to use it for professional reasons, unfortunately, right? There's very few areas where you can use this, right? But maybe this will be a year of Prolog someday, right? So, but it's really kind of fun. So we can add more facts. Let's add more facts. So likes, likes. I don't know. Peter's likes, I don't know, anchovies, right? So working on this. Let me run on the code. Yeah. All right. So as friend Valdis and Peter's, of course they're not friends because, right? Peter's, right? So false, right? Because Peter's likes anchovies and Valdis really does not like anchovies, right? Of course, we could do negation as well, right? So the basics are facts, right, and rules, right? And we'll also have negation, of course, and right things like that, right? So facts, we can have multiple facts, but we don't. These are two. These are two binary facts, right? It's a true statement, right? Now let me see again if I remember correctly. Oh, but who's calling? 1 second. Yeah, klausos. Darbā? Skolas ielā. Jā, nu. Tas ir, kad iet no slimnīcas uz centru. Ļoti slikti. Es tev, tu vari atnākt diezgan šeit, tad ir šoka galvas vienkārši. Jā. Kur? Uzran rūtē būtu, jā. Jā, un es došu uz 5, jā. Jā. Alright, no. So basic facts, right? So let's see. We can do some commenting out, right? So doing this right now, we can have a comment. Let me see the syntax for Prolog. No, hello world. Yeah. So question. I think this was I don't know. There should be a shortcut. Is there a shortcut keyboard? Right. Because I would like to comment this, right? So if I comment, I believe as this is a comment, right? So this means, of course, sims of Prolog programs. So Prolog programs consist of facts, right? Rules, right? And then queries that, that to the Prolog system, right? And that, where Prolog inference engine, let me see this here. Engine answers them. All right. So obviously you could also do it. You could do the query here as well. All right. All right. So let's see before the break. Let's see what else. We had a hello world. Yeah. So the tricky part is now how do you do a hello world, right? Right. There's a write message basically, right? So we could make it this idea, right? So this is an idea, this is one way of doing it, right? So let's do this. Hello world, right? This is a fact, right? Hello world fact, right? Right. So let's take a look at this. I'll update here, basically, right? Usually, of course, you want the predicates to come afterwards, right? So hello world is just a fact. But hello world is actually hello world, right? And then we are gonna run this inference, right? So basically, look at this here, right? Right. So print hello world, right? Hello world message, right? It will try to match, right, to something, and then write the message. And of course, you know what NL means new line, of course, right? So kind of tricky. I mean, so let's do this again. Let's see if there's any errors. It shouldn't be. Did I run it? Hope I run it. I can't remember. No. So if I do print hello, right? And it works. You see, hello world. But what's interesting, where the joke about Prolog always answering something, it answers true, right? Because it found a way of running this, right? Hello world, right? So the question is, what happens is if I do another fact, right? This is okay. Hello world, right? Sub RT or sub RBS, right? Right. That's another fact, and of course I need to include a dot. Can you guys see this still? Can I make this bigger? Yeah, I can make this bigger. All right, that's better, right? So now we have two facts, right? So which one is going to match? We'll see, right? I'll run this code. That's not complaining right now, right? Let's do this again. It's probably going to find this one, right? Yeah, but notice something. I have another way of printing, right? Hold and sub RBS, right? Because there are two facts, right? So both those match, right? So my hello world actually, right? So this is a predicate, right? It's kind of, it's not really a function, really, right? But kind of, we sort of made it look like function, really. So do something, right? So print hello, right? It's like a predicate. There's no. I notice here there's unbound variables. Here you have a variable, right? But this variable is assigned to this. Immediately you get some value and you write to a new line, right? So yeah. So the things. So the kind of hard things are easy in Prolog, like the queries and logical things. Unfortunately, the really easy things from other languages are kind of hard, kind of painful in Prolog. So it's kind of trade-off. It's a trade-off, like in everywhere in life. All right. So let's explore more features, and then maybe we'll do some running, right? So we could run the program, of course. Right. So syntax. So let's look at the syntax again. So dot, right, friends, head, body, facts and rules, right? Not so hard at all. John, Jane, John, Jack, Jane, right? Who likes who, right? So, in case you see, common interest could be people, could be pizza, right? Prolog that makes no judgment, right? Whether you're friends because you like the same person, or maybe you are actually like because you like same food, right? So, head, body, right? So implicates, right? Friends are XY if they do something. And again, you can make more complex statements, right? This is only 2 arguments, but you can have more than 2, 3, 5, or you have 0 arguments, which is kind of, well, for facts, kind of not really useful, but you can have single person arguments, like here, for example, right? We sort of like said, hello world is a fact, right? It's true fact when its value is hello world, basically, right? So single argument fact. Now, so this one's pretty decent, right? So it's declarative. We declare the knowledge, right? So you define what you want to achieve, but you sort of say, okay, the how, the answers, it's sort of like a black box for us. Well, not really a black box, but really as a usual Prolog user, we don't really, it's not our, usually we don't worry too much. Well, later on, for more complex programs, you sort of start to think about how it figures out the answers, right? So like sells chocolate, right? So loves, right? Likes and trusts, right? Right? If somebody loves something, so love is if somebody likes them and also trusts them. Okay, right? You can go with that, right? All right, lists. Right, we'll get some lists. That's next on Thursday. We'll get some list action, maybe more. Right. So one thing is really that is important is the facts, order of writing facts and rules matters, right? Because Prolog does so-called depth first search, which you guys know from algorithms course, right? So it matches the first rule, second rule, and so on, right? Usually you have some parents, yeah. So this is a very basic program, right? So parent, right? Right, we can do this. This is like one also very simple program. Let's do this. I'll Control Z. Sorry, I didn't want to do that. I will put it inside I'll make a new notebook, right? Because I create a new notebook, and I will make a new program. Good. So Control V, right? Albert, Jim, Albert, Peter, Giant. So who is who, right? And right, this is like the classical. This is more like Hello World of Prolog. And then of course you need some rules, right? Who is child, who is the grandparent, right? Right, grandparent relation. We define the relationship. So facts usually come first, right? Rules usually come after, right? Siblings, right? And look at this here. So this is kind of interesting. Already we get some more extra action. So child, right? Is if you have parents. So it makes sense, right? Back and forth, right? Child are really easy to define, right? So grandparent and grandchild is somebody who has a parent who has a parent okay. So who is a parent to somebody, right? And this somebody is parent to somebody else. So then of course GP then is a grandparent to grandchild, right? Makes sense completely these relations, right? So child same. So siblings, meaning you have common parent, right? To be half siblings, right? In this particular version, right? So XY, parent X. So there's some parent, right? I mean, you have 10 parents, I don't know, genetic modification or something, but still, in this case, at least as long as you have one parent, and notice something else. There's a new rule, right? New action, so not equal, right? Very important, right? So they're not siblings, right? You are not sibling to yourself, right? So, okay, let's try this one. So what do we have? Albert, Jim, Brian. So let's let's take who is a grandparent, okay? And we run it. So let's find out, since I'm lazy, I want to find out who is a, I can do it completely, since this is small enough program, any GP, right? Any GP and any GC, right? Completely open-ended, right? Question. Find me all grandparents and all grandparent grandchild relations. This is kind of dangerous query, by the way. Dangerous query because, of course, on a large enough knowledge base, you get too many answers, right? So here, let's take a look. All right, Brian Albert. Brian is parent. Okay. I'm gonna correct any grandchild. Brian is the child. Albert, right? Jim makes sense. Okay, there's gonna be more. But Anna is a child. Albert also has a grandchild Anna. Let's see if that's true. Albert, right? Jim, because he has two children. He has two sons, Jim and Peter, right? Yeah. So Peter and Anna. I think that's. Let's see, is there anything else? How about that's it? Yeah. So false, meaning that's it. So knowledge base is exhausted, right? So kind of cool, right? So now how about siblings, right? This would be what? Jim and Peter, right? Same pattern. Albert's the father. How about, I think that's it, right? Jim and Peter are siblings, right? I don't see any other ones in this particular case. So sibling, any S1 or any S2, right? Something like that. Jim, Peter, but is that it? What do you think? In this particular,
should be.
yeah, it is really. That's it, right? However, and this is again where Prolog gets kind of tricky. Well, let's see. What do you think? There's going to be. You see, there's another answer. Which one do you think? What the answer is? Any?
Peter and Jim.
Yes, there's Peter and Jim as well, right? Because these variables, they're completely. We didn't define any other restrictions, right? So whichever comes first. I mean, so they are both valid statements, right? Peter and Jim. Because there's more. Let's see who else is there. And then, no, that's it. That's it. Okay, so yeah, all right. So yeah, so that's again some challenge already. I'm sketching in some challenge which you'll have as your Prolog programs, right? They are kind of fun to write, right? Until things don't quite work as you expect, right? So, all right, but at least you have the basic idea. Okay, before the break, let's see if we can install it locally, right? I have a notice here. I mentioned, of course, you have if you're on Windows, right? You can install it. I mentioned here, right, the installation, right? So I'll do update on Ubuntu, right, and install Prolog. I don't really do the update, but let's take a look, right? Since you can try this, so this should work. If it works for me, it should work on your code space as well, right? You don't necessarily have to do it. Come on, yeah, allow pasting. This will see. Oh yeah, let's update some Ubuntu packages. All right, and now we do. Should be pretty painless. Sudo apt-get install, right? Just usual update, install program update. All right, this is an Ubuntu, and hopefully, yeah, 8 gig, no, like 50 megs, and not too bad. All right, did not do something, but let's see. All right, seems to work. Let's make a new program. Do we have a closure project? Let's make a new map. What do I have here? Or do I have it here? Let's look at one more map. Prolog programs, Prolog projects, Prolog projects, right? And we'll go here. I'll make a new program. So let's do this one here. All right. Now we need to remember what the file extension is. That might be a little tricky. Right. So let's see first. Can we do the interpreter, right? So it's like a, yeah, it works, right? So friends, right? No. Alice and Bob, right? Oh, why didn't it like it? I said friends, Alice, Bob. I thought this would work. Maybe. Oh, that's it. Oh, friends too. Okay, I have to define. I guess I need to. Oh, this would be for queries, I guess. Unfortunately, I guess you have to. I thought you could do it immediately. How did you? And now, of course, I'll do Control C, but it works. Control C. All right, I can't. Yeah. Exit. All right, we quit. Right, so I don't know why the friend. You see, it says there's no. I thought that this would be enough to define it, right? But I guess there's something else you have to do it to define the fact, right? So interactively, need to look it up. But let's see here. Oh, here's some closure installation facts. So running, yeah, this PL. Consult. All right, we could do this. Consult. Yeah, let's try this one more time. So my program, so parents will go to CD Prolog projects, right? This SL, right? And this will make this a little bit bigger. You can see this right now better, I hope. So we are here. There's no files, right? I'll make a file here, parents, right? Called parents. Family, right? Family PL. I think it was PL, right? Unfortunately, PL I think is also used by Perl, if I remember correctly, right? So family. Let's do this. This is not Perl. You see, it thinks it's Perl, but it's not Perl. It is actually, all right? So It's not a, so I need to, of course, I maybe need an extension also. Prolog extension would be nice. I think it's a Perl, but no, it's not. All right, so now let's run it. So again, swih pl, and let's do consult. So let's do this family, and we need to install it pl. Let's see, is this gonna work? Oh, don't, oh no. Ah, phone family NATO. Oh, let's see, we didn't like. Didn't like something else. So running is a little bit tricky. Consult. My program. Consult. This should work. So let's take a look again. One more time. So family. Okay, true. All right. So it worked. Okay, now it should work. So now we can use it, right? So let's do again sibling, right? Let's do this one here, right? We already had this. So sibling dot given pattern, it works. So it works. So the program works in interactively, of course. I'll do one more. Maybe we can continue. Maybe continue. 1 second. 1 second. All right. Let's take a break for till let's 2:55. Yeah, that's okay. Right. So see if you can install it yourself. See if you can get some queries done, and we'll continue afterwards.